So to finish section 1-2, we're on page 20 here for the final video. We're just going to finish up the last couple questions in the course pack. And these questions are really focused on, can you read a pie chart? So the first part was, can you create one? So now you know where this thing came from, that there's a set of degrees that correspond to that 70% and then 1% and so on and so forth. So this is one, a survey that was taken in the USA Today. Notice this, you should be very suspect of the answers here. So people's hand washing tendencies when using a public restroom. The question is, how did they answer these questions? Was someone standing outside the bathroom and asking the person, did you just wash your hands? In that case, there's probably maybe a large amount of liars here, people that are misrepresenting their answers. You should always be mindful of how is data collected. Okay, so at this point, the first question is the sometimes category. Right here fills 29%, and the never category just 1%. How many degrees do each of these sections cover in the pie chart? Well, we know that the entire pie chart is 360 degrees. So if I want to figure out the sometimes category, I know that 29% or 0.29 times the 360 degrees will represent the number of degrees that that sector takes up. Likewise, for the never, since I know it's 1% based on the pie chart telling us that, just calculate 1% of 360 degrees. So this one's I can do easily in my head, just move the decimal place 2 places to the right. That's 3.6 degrees for the never category. For the sometimes category, I'll go ahead and use a calculator, in this case Desmos, to get that value, 104.4. So the second question, what do you think the percentage would be if the question was, how often do you wash your hands after using a public restroom when no one else is in there with you? Again, we're going to have to trust that the people would answer that accurately. And really, he's thinking like, hey, do we just wash our hands because it's gross if you don't? And if there are people that are watching, you're more likely to do what you're supposed to, just like you're less likely to speed if there's a police officer driving in the lane next to you than maybe you are if there's no police officer around. Who knows? Okay, moving on. I'm going to skip this part where we build the pie graph because we already did it. I am not ever going to ask you to draw one by hand. You're certainly welcome to if you want. And we're going to move right on to page 23. Here is a description of what I showed in the previous video of how to put a pie graph in Excel, which you're going to have to do for project 1 if you're using Excel. You can also use Google Docs, and I'll have videos to show you how to use Google Docs. All right, a couple more questions on interpreting pie charts. So this pie chart represents a national survey of students working. So how many hours a week do you work? And this was back in 2003 and 2004. So which range of hours was the most common? Well, how we tell is we look at the percentage that is the largest and notice it's the 1 to 20 hours. Now that's a huge range, right? There's a big difference between the students that are working 20 hours a week, which is a part-time job, and the students working 1 hour a week. All right, what percentage of students work between 21 and 34 hours per week? So again, this is just, can you read the graph? Here's that sector, 21 to 34 hours, and that is 21%. Now, if we want to know how many degrees make up the angle for the sector representing students who work from 1 to 20 hours per week, we know that this angle measured in degrees is 35% of the total degrees in a circle, which is 360 degrees. So like before, let's just calculate 0.35 times 360. Again, I'm going to rely on Desmos to do this calculation, and I get 126 degrees. All right, finally, I'll ask you questions. So we're told that on a campus of 7,500 students, on average, how many would you expect to work at least 1 hour per week? Well, this is a special word, this at least 1 hour. That means 1 hour or more. So if we look at our pie graph from the previous page, 1 hour or more is actually all three of these sectors. The only one we exclude is the 25% sector. So if we add up these three percentages, we know that 75%, based on our survey, of students work more than or at least 1 hour, so 1 hour or more. So to calculate how many of our campus would follow that, we would use 75% of 7,500. So we'll skip over to Desmos for that again. And I'm getting 5,625 students we would expect to work at least 1 hour a week. Okay, and then on a campus in question 5, how many students would you expect to work less than 21 hours? Okay, so again, looking at our graph, less than 21 hours is cannot include that 21 hours, so it would be this sector, the 1 to 20 hours, and the none sector. So we're going to add together 25 and 35%. So that's 60% of our campus we would expect to work under 21 hours. Again, 0.60. That's converting that percentage to a decimal. And let's run to decimals one more time to do this calculation. I get 4,500 students, based on that calculation, we would expect to work under 21 hours. So this last question is just, what do you think? How do you think these results would compare with a similar survey conducted for this school year? This to me would be interesting to think about. You've got the pandemic going on, so maybe there's a lot of people that are either out of work because of the pandemic, or maybe there's more people working because of the pandemic to help offset lost wages. We're a community college, and that means many of our students are part-time or working, so you're not really living on campus. That has a big factor on the type of students that come. Like a university, when I went to university for undergrad, I lived on campus. The majority of my classmates lived on campus, and that was like our full-time job was going to school. I worked tutoring and other things, but I was what we tend to call a typical college student.